Okay, so this is one problem, initial value problem from section 4.8. In this question, we have given second derivative of r and the value of the first derivative of r when time t is 2 is 4, and then value of r when t is 1 is 1. So these are the three information we have given. We would like to find out the function r, which is function of t. So you have second derivative. From second derivative, you would like to find out the function itself. So here, first of all, you have to understand the meaning of relation between the derivative and antiderivative. If you have a function and if it's a differentiable function, you can find out the derivative. But if you want to go back, that's called antiderivative, reverse process. You have given a derivative of a function. Going back process gives you the value of the function. And there is one formula you have to understand. If the derivative of the function is t to the power n, then the value of the function, which is going back process of this operation, there is a formula which is equal to t to the power n plus 1, get here, n plus 1 over n plus 1. Okay, so by using this formula, we can solve the problem we have given here. So in our case, instead of f of t, we have given r. Instead of one time derivative, we have given two times derivative. So this 2 stands for two times derivative of this function r it's given, it's 3 over t to the power 4. So I can write down that t to the power 4 as a t to the power negative 4 as an exponent. So my goal is to find out this r of t, but to go back, you can go back twice because it's a two times derivative. So if you apply this rule one time, that will go from two times derivative to the one time derivative. So that will give us d over dt r of t equal 3 times. You can use, because we are going from derivative to its reverse, so it's antiderivative, we can apply this rule here. So t to the power negative 4 plus 1 over negative 4 plus 1 plus a constant, let's say the first constant, because there are two reverse process we can apply. So I'm using first constant, c1 as a first constant. Okay, so that is the first equation I can get. By applying the same trick, I can go back again and I can find out the r of t, which is going back process. But this time I need to find out the antiderivative of this particular part plus this one. So there is a formula for this power rule. You can simplify this. 3 over negative 3 is negative 1. 3 over negative 3 is negative 1. And here it will give you t to the power negative 3. So the only left over here is t to the power negative 3. So let me just simplify this here. It's a negative t to the power negative 3 plus c1. Now we would like to apply that antiderivative rule here, the very same rule, the power rule, this rule. And this time for the first term n is negative 3. So by applying the very same rule, this n, I'm going to get t to the power negative 3 plus 1 over negative 3 plus 1 for this part, plus the antiderivative of constant is always that constant times t. If you don't remember this formula, you can check your notes, or go back here and what is that, week 12 video section 4.8. If you click that video, you'll be able to see this relation, okay, for the antiderivative. Okay, so by using that, we can find out this second equation, plus constant, second constant. If you check this formula here, you can see that this antiderivative of x to the power n is this one plus constant. Okay, so now we have two different equations, and if you look at here in these two equations, there are two different constants, c1 and c2. So to find out the value of r of t, we need to find out the c1 and c2, and for that we can use the given what is that we can use the given relation here. The value of the first derivative when t is 2 is 4, the value of r when t is 1 is 1. So we can use this fact here. That's called situation or initial value. These are called initial value. Okay, so let's simplify this one. If you simplify this one, the second part, it will be this negative 2 negative is positive, so it will be 1 over 2 t to the power negative 2 plus c1t plus c2. That's our equation 2. Now let's use the initial condition. The initial condition is the value of the derivative of r when t is 2 is equal to, I think it's a 4. That's 4. Meaning, if you go back to this equation 1 here, this one, the simplified form, and if you put t equal 2 here, that should be equal to the 4. So that means it's a negative 2 to the power negative 3 plus c1. Okay, and now if you simplify this one, it will help you to find the c1. So this is 4 equal negative 1 over 8 plus c1, and just add 1 over 8 both sides, and that will give you the value of c1. So if you add this 4 1 8 8 over 8 plus 1 over 8, I'm just trying to make the same denominator, that's c1. 8 times 4 is 32 plus 1 is 33 divided by 8 equals c1. So that's the value of first constant c1 by using this initial condition of the first derivative. And now we can also use the initial condition for the value of the function, like when t is 1, r is 1 in second equation. So we can see that when t is 1, r is 1. So that means if you go to the second equation here, put t equal 1 here on the right side as well, it will give you half c1 plus c2. I think that's half, no, it's half 1 to the power negative 2, which is 1. So half plus c1 times 1 plus c2. So half plus c1 plus c2. But here we already know what is c1 is, so just put c1 equal 33 over 8, and now simplify for c2. Just do the simplification here. So c2 is 1 minus half minus 33 over 8. So just make the same denominator, so that would be, let's say, 8 over 8, 4 over 8, 33 over 8. By making same denominator, you can write 8 minus 4 minus 33, which is eventually negative 29 over 8. 29 plus 8 is 37. So c2 is negative 29 over 8. So now if you go back to this equation and this equation 2, you have the value of r, and you know the value of c1 and c2. Just replace this c1 and c2 by 1 over 8, sorry, 33 over 8, and negative 29 over 8. So r of t, which is if you go back to equation 2 here, it's 1 over 2 t to the power negative 2 plus c1t plus c2. This is r of t we found, but we don't want the answer, we don't want our answer in terms of c1 and c2. So we can write it down this term as a 1 over t squared. We don't want our answer as a negative exponent, so I'm just changing the position, and now I'm just plugging the value of c1, which is if you go back and check your c1, which is 33 over 8, and C2 is negative 29 over 8. So that is R of t, and that's our final answer. So this is here R of t is, what is R of t? What is that? Half 1 over 2 t squared, right, plus 33 over 8 t minus 29 over 8. Let me check one more time. 33 over 8 minus 29 over 8. Okay, so that's the answer. Let's check the answer here. Okay, excellent job. So the thing is, you just have to use that antiderivative formula 2 times, and when you use that formula, it gives you constant, 2 different constant. You can find the value of those constant by using this initial situation, and that's why it's called initial value problem.